my perspective, because I grew up with a lot of this technology, so I guess I'm accustomed to it. So I feel like maybe I could offer a fresh perspective on where this technology is headed in the next 10 or 20 years. First of all, I apologize. I realize that you're all much smarter than I am. So if this isn't up to your expectations or how you expected, then I apologize. Also, I have a bit of a cough. I was hoping the nice French air would be able to fix that, but maybe a day or two. So as a kid, I used to watch this show. I'm not sure if all of you were able to get it in your country, but it was called The Jetsons. And I grew up with this show, and this family, The Jetsons, is set in a very distant future. They had this maid, this robotic maid called Rosie the Robot. And this is Rosie, and what she did was she was able to clean, she was able to help the kids with their homework, she could cook. She basically did everything that a housekeeper would do, a maid would do. She was, in definition, the ultimate robot for me as a kid. And this is how I got interested in this field. I wanted to understand how maybe we could build something like this in the future. Because I realized that that was set in maybe a few hundred years from now. But as technology gets better, it may be a lot closer than even I think. So I wanted to do some research on just the history of the word robot, or even just robots themselves. So the term robot was actually introduced in a 1920s play by a Czech man named Karl Čapek. I'm not sure if I got the pronunciation right, but I had a friend from Slovakia help me out to. And he had this play called Rossum's Universal Robots, or RUR. And originally he wanted to call the term robot, he wanted to call it delnas, which means to work, which is derived from the Czech verb delat. But he had a brother named Josef Čapek who came up with the name robot. And this word actually meant the same thing as delnas. It's from an older version of the Slavonic language, where the word is rabota, which means servitude. And it actually, in Czech, it also actually means work or labor. And interestingly enough, though this was all said in Eastern Europe, all these words come from the Indo-European root orb, which also means work. So I've read this play, I've read excerpts, I've read summaries, and I'm not sure if any of you have read it, but if you have, then in this play, you would know that the robots weren't made of metal. That surprised me because whenever we think of robots now, we think of machine parts all working together made out of aluminum, steel. Maybe there are some experimental plastics out there, but mostly it's all been metal. And it surprised me when I read this play that the robots actually weren't made of metal, but rather they were molded out of a chemical pattern. So of course this is science fiction, but there was actually a reason they were molded out of a chemical pattern, because this pattern was able to be manipulated very easily for the sole purpose of looking exactly like humans. So Karl Čapek was very ahead of his time. He was thinking about these robots, but in essence he actually envisioned the very first android. And so yeah, he created a more android-like robot than he did what we think of today as just a robot, which would be kind of a device with maybe wheels, gears. So these androids, or these robots, could do the work of 2.5 humans. And in the play, they were created just to simply ease the lives and convenience the humans that were making these robots. And I feel like that's what we're doing today. We're building these robots. We're calling for all the standardization so that we can make our lives easier. We can envision for the future. Unfortunately, the tragic ending is that the robots rebelled and killed every human there except for one. So even in the 1920s, he created this fear, and I think there are still some people today that have this fear of maybe, yes, if we create these androids, then they might get smarter, they might want free will, and they might rebel. Hopefully that doesn't happen, but it's still a very constant fear. So what is a robot? I wanted to know just more about the definition of a robot, the modern definitions. I always thought that it was just a machine that can perform tasks. But that would include a lot of things, like a toaster, maybe an oven, because those are all machines that can perform tasks. I don't believe that those are actually robots. So what I did was, I researched it, I just looked it up on dictionary.com. And I found that a robot is, in essence, any machine or mechanical device that operates automatically with human-like skill. In essence, it mimics human behavior, but it's not a human, it's not biological. It's a machine. It's engineered specifically to mimic human behavior. Since this is a wireless robotics seminar, I wanted to find out what wireless meant. I grew up with a lot of, 2003, the wireless laptop was more mainstream than it was maybe a few years ago. I grew up with a lot of wireless technology, and I always thought when I was young that it just meant having no wires. But, I mean, if you have a lamp and you take out the wires, then it's wireless. No, it's not wireless, it's not functional because it took away the wires. So, when I looked at the definition of wireless up, I found that it notes or pertains to any of the various devices that are operated with or actuated by electromagnetic waves. And I found that this was a much better definition because, though at the time I didn't know what the electromagnetic waves were, I realize now that anything wireless is when you send out these electromagnetic waves, it causes these wireless devices to perform actions. So that's what I realized wireless technology was. It's these electromagnetic waves. Yes, they have no wires, but it's much more than that. So when you put them together, what are wireless robotics? So in 8th grade, I took a robotics class. It was an elective. And I was actually fortunate enough that we had a conference call with NASA, which is our government space program. And we had this conference call, and I was in 8th grade. I didn't really know what I was doing there. But one of the engineers there asked me, what do you think a wireless robot is? Or what do you think a robot is? Yeah. And I said, it's just a machine or a system of machines capable of teleoperation or autonomy. Which means that it can be either operated remotely or it can operate on its own will. Well, I shouldn't say own will, but it can be operated without any human interaction. So she said, I was actually lucky, she said, yes, that's exactly right. So for years I lived with this definition of, okay, it's a robotic system capable of teleoperation or autonomy. But I think in similar terms, it's just a hybrid of the two definitions I gave before for robot and wireless. So I think it's machines or devices that operate automatically with human-like skill. I think that's the important part, that it mimics human behavior while still having no wires and using these electromagnetic pulses. But I don't think it's still that simple. I think that this is a very good base definition, but I think that as technology advances and when you get to these higher levels of complexity, that this definition is no good. I think that it's still a very good basic term, and maybe in 10 years if I'm talking to a class of maybe 8th or 9th graders, and I can give them this definition, but when you're talking to maybe college students or more advanced people, then you have to get a little more advanced in terms of the definition. So, how did we invent wireless technology? How did humankind or mankind invent this wireless technology? Well, there's an Italian physicist named Guglielmo Marconi, who I'm sure everybody knows is credited as the inventor of the wireless radio, and he created this first wireless technology. So he's first credited with the invention of wireless technology, but there's also another man, an Indian physicist named Jagadish Chandra Bose, who not a lot of people credit as having this first wireless technology, but in 1895 he was published in a newspaper for having sent information wirelessly over a mile. Now Marconi knew about this, and still he decided to get patent rights for it. So I'm guessing intellectual property is important because not a lot of people credit Mr. Bose for having this effort. And I still respect and credit Marconi because what he did was take that base technology and he made it a lot better. He was able to turn it into something more usable, more user-friendly. But I still believe that we need to also give credit to Mr. Bose because he is the one that created this first technology. And several years before Marconi did. Now, regardless of wireless technology, man's fascination with robots goes even further than the 1920s, which was Carol Chapek's play. That's when it was published. Let's take a trip back to the 16th century. There was a young inventor named Leonardo da Vinci. He was 12, so before the Mona Lisa, before the Vitruvian Man, before any of his more popular works, he created this design for an automated robot. And this was the 1500s. He created this design that it was operated by a system of pulleys and gears. It was basically the first robot. It could be manipulated to fit the human need. And this robot was, he actually had a working model for it, which is extremely interesting because he was 12. And I know I wasn't doing anything like that when I was 12. So it's just, I mean, of course, Leonardo da Vinci is one of the greatest inventors of all time, but it's just interesting that at such a young age, even not just Da Vinci, but mankind had this fascination with robotics. And even going forward, back from the 1920s, past all that, to the 1970s. 1977, my favorite movie was released, Star Wars, Episode 4. And it featured these two robots, C-3PO and R2-D2, which were, of course, wireless robots. And I feel like the point I'm trying to make is that throughout this time period, several hundred years, we've never lost sight of this desire to have automated robots to assist us and to ease our lives. So even in the media, George Lucas had this vision, and I think it stems all the way from, I don't know if he knew it, but even from Leonardo da Vinci's idea in the 16th century, it still stems from this desire to want automated robots. So we've always wanted these automated machines to assist us in life. Now, even further still, let's go back 10 more centuries, or 1,000 years even, almost. Let's take a trip to India in the 11th century. It's AD 1050. It's the kingdom of King Boja. And if we were to see this, we would see that machines were used in the construction of monumental buildings. Now, there's an ancient text called the Vastu Shastra by the author Shukla. And quoting from this text, he uses a reference to men machines serving as servants and soldier machines, basically androids and robots. So even several hundred years before Karl Čapek's play of androids and robots, we had written reference to these androids and robots kind of working in conjunction with humans to accomplish a similar goal. Now, if you just let me read this to you, this quote from the Vastu Shastra, it's that each part of their figures is made and fitted separately with holes and pins, so that the thighs, eyes, neck, hands, wrists, forearms, and fingers can act according to the need. So basically, these robots had a very big range of mobility. They were extremely dexterous. And it just amazes me that in a time when most civilizations were just trying to figure out how plumbing works, that they had these kind of advanced machines to be manipulated and changed to fit the human need. So, going back from 1050 AD today, 2011, I pulled this off of the IEEE website. It's from 2007. But a year before that, the world robot population, it says there were about 4.5 million. In comparison to the human population, that's not much. However, they had a projection in 2007 for 2010, and they predicted about 8.37 million. Now, I wasn't able to find the exact number, so maybe one of you can tell me, but if it's anything close to 8.37, that means in 4 years the population nearly doubled. Think about that. That's like the human population going from 7 billion to 14 billion by 2015. And I don't think we can cope with that. So I'm not sure how we're going to cope with this kind of growth in robotics either. But think about it. In 2020, where could we be? We could be in such a greater position. We could have so many more robots. And I believe that even by 2020, we could have a personal robot in every home. So what can we do to enable this kind of growth? I think that there's a lot of things we can do. I think we need to standardize, because I think that would help with the ease of compatibility between technologies. And if you look at the chart, you'll find that Japan is actually the worldwide leader in robotics production and usage. And not only by they lead compared to all other countries. When you put all the other countries combined, they still have a majority. So Japan is obviously doing something right. They're producing these robots, and they're also finding a way to use these robots. So what we need to do is we need to standardize so we can replicate this kind of growth and interest in other countries. If other countries see that, oh, now that we have compatibility with this technology, if it's standardized, then they can be excited by these wireless robotics as well. And I think that one day we could produce as many robots as Japan can as well. Because, I mean, I understand that they're extremely smart, but I believe that we have the capability of matching those levels of robotics production and usage. So why go wireless? Well, the point I'm trying to make is that these robots are trying to mimic human behavior. So I don't have wires. I don't need to be plugged in every night to be charged. So why should robots? I feel like if we're trying to mimic this human behavior, I don't think that I don't get plugged in every night. Why should a robot get plugged in every night? In order to wire a robot, it's also very complex, very costly, and those wires can inhibit mobility. The point is that a robot is as dexterous as I am. Well, I'm not very dexterous, but a normal human. So a robot is as dexterous as most humans. So we have internal wiring, yes, but it's not significantly enough to inhibit our mobility. There's also a very good system of control. You can operate from a very far range rather than several extension cords, and that can get very problematic. So there's also self-regulation. It can manipulate itself. It can regulate itself. Yes, of course, you're not restrained by cords. You have more freedom. So that's why I think we should go wireless with all technology. So what wireless technology do we need? I mean, what technology do we have to implement into tomorrow's wireless robot to get it to meet the needs of society and to meet the needs of all the researchers that want this robot to be put in effect? So there are several types of technology available on the market today. There is Wi-Fi. Everybody knows Wi-Fi. We all use Wi-Fi for our phones, for our laptops. It's basically in a room. If you have a Wi-Fi sensor, or in a house, you can operate using Wi-Fi from any room in that house. There's also Bluetooth. Everybody has a Bluetooth headset. Bluetooth is maybe inside a room in that house. You can operate Bluetooth. That's the kind of range. There's also near-field communication, which I didn't know much about, or I didn't actually know what it was until I saw this image. And I realized that I've seen this before several times because it's just basically if you're operating from a very close distance to the base unit, then it can be wirelessly used. And another thing is that I never realized that all of these technologies can be put inside a robot. I always thought that, Wi-Fi is just for internet, Bluetooth is just for cell phones or my PS3 headset. So I realized that we could put these technologies inside a robot, and that could make it more effective in terms of wireless compatibility and range. There's also the Zigbee chipset. I didn't actually know what the Zigbee chipset was, so I looked it up, and it's a chipset that it's relatively short range, but it's also extremely energy efficient. And I believe it's also IEEE standardized, which I think all of these are. And then there's LTE, which is a long-term evolution network, which is for operation over many kilometers, many miles. So it's a very large gap, very large distance. You can still operate wirelessly. So should they have one or many radios? Radios inside a robot, of course, mean for communication. Ideally, they would have one. It would keep it cheap. It would keep it easy to use. It would keep it simple. However, I think at the minimum they need two, because they need two types, which are sensors and communicators. The sensors are, of course, for awareness. The communicators are for interaction. In reality, they'll probably need maybe 3 or 4 of these types of technologies, but at the minimum, they're going to need 2. So it's not as easy as I'd hoped, where we could just have one kind of radio, one kind of technology that would just be put, you insert into the robot, it automatically works. It's not that easy. And I'm coming to terms with this because I always thought maybe one day I could create something like this, but I realized that there's a lot of work to be put in. So robots are getting smarter. Scientists are also getting smarter. They're making this technology even smarter than we are. And scientists have predicted that by 2020, robots will be as smart as we are. So I don't think that's true, because though we can make a robot very, very good at one thing, I don't think we can make it good at a lot of things at once. We humans are unique in our ability to multitask and to operate various fields very efficiently. So this is IBM Watson. IBM Watson recently beat the 2 biggest Jeopardy champions by quite a significant margin to win this Ultimate Jeopardy tournament of man versus machine. However, there are 2 things to be noted here. That one, Watson is a computer. He's not technically a robot. So it's very difficult to compress this kind of Watson-like technology into a very small personal robot. I think that though we can have this kind of computer technology, I don't think we can make it some kind of wireless technology very soon. And also, there's a lot of things Watson can't do that Mr. Jennings and Mr. Rudder can. Watson can't cook. He can't write a story. He can't tuck his kids in at night. There's a lot of things that Watson can't do. But I believe that, yes, robots can do one thing very well, maybe 2 things very well. they can't do everything very well. And I think that that's where eventually we need to be headed. But I don't think that by 2020 it's going to happen. I think that's way too early. However, they've also predicted, some journalists at CNET, they predicted that by 2045, singularity will occur and robots will merge with us. So, I read a lot of science fiction, so I didn't really know what singularity was, but I was familiar with the concept. And basically it's that man's desire to store more information and better themselves, and the robot's intelligence will both be at such a high level they'll converge, and man and machine will become one as a kind of cyborg. So, this is just kind of where apparently we're headed. And I think that by 2045 it's very possible, because if someone came to me on the street and said, hey, next year we'll have singularity, I wouldn't believe that, because I don't think that's possible next year. I really don't. But 2045 is a long way off. We've come so far in 20 years from the 1990s, 1980s to 2011. So by 2045, I think we could be even better than we are right now. We're manipulating laws, we're creating new technologies. I think that by 2045, this may be possible. So with all this technology, what can we do with it? Theory is great. I really like theory, but the point is that we have to implement this technology in the real world, and it's nothing without practical application. So that's basically the point of the presentation, is to talk about the practical applications. And the good thing is, the nice thing is that there are several fields that could use this technology. Practical applications are seemingly endless. So there are so many things that we could do with wireless robotics that I don't think we're ever going to run out of a need for this kind of technology. So the first application is, of course, governmental military. I'm not a big fan of war, but to defend the nation, we could have an all-robotic defense force, and I feel like we could save human lives. We could maybe steer away from human soldiers, have wireless robotic soldiers, so we could save human lives in the process, and we could save civilian lives as well, because these are very accurate, and robots could one day fill the entire military force. So I just want to show you one clip. It's a news article actually. So.
This is what the future of remote robotic warfare looks like. Gecko, an unmanned ground robot, is just one of the military prototypes presented at the European Land Robot Trial in Germany. The primary function of many of these units is reconnaissance. Top priority is to keep troops out of harm's way by first sending in the bots to scope out potential dangers. Another focus is facilitating transport. By deploying remote control vehicles, soldiers can focus on other tasks, such as enemy whereabouts. And despite all the high-tech cameras, laser sensors, and mechanical arch, experts say they're still waiting for a breakthrough in reliability and autonomous operation. Narrowing that gap, they say, could help push these vehicles from the support lines to the front lines.
Okay, so as he said, they could be going from the support lines to the front lines, because I think there are two problems. If you saw that one reconnaissance robot, you saw that not too far behind was the soldier operating it wirelessly. I think that obviously the point is to send that in first, a good distance away from the actual troops. But if you have someone walking behind it with the controller, then of course it does no good. You might as well just send that person in, looking with binoculars. He does the same job. However, I still believe that this is kind of a breakthrough in technology, because I never thought that a wireless tank was possible that could go in any terrain, operate by itself. Of course, there are drawbacks to autonomy and kind of range of motion, but still, this is new to me at least. It was surprising to see that we have something this impressive and this advanced already in this day and age. This is from 2010. So it just really surprised me.
This is
So the military is great. They have their defense budget, they have all this, but regardless of the military's budget, the largest market for wireless robotics is in the house with the average consumer. And I think that though there are top-level or top-level government agencies that are very advanced in the field of robotics, the average consumer is not as intelligent as a lot of these top-level people. So I think that we need to make them more user-friendly. And it's surprising that there's a lot of robots today that have actually been in existence for years in places that even might surprise you. So that first robot I was talking about on the Jetson, it's really the robot. It can clean, right? This is Roomba. Roomba is a wireless robot. It operates by itself. You just turn it on, you put it on your floor, and it actually cleans your floor, it cleans your carpets. It doesn't bump into anything in a sensor, it just stays a good deal away from, there's a chair here. It'll operate, it'll know that there's a chair, it'll move its path, and it'll clean still. So this is mankind's answer to Rosie the robot. This is where we are right now, and I think that's really impressive because it looks like a big picture. It's actually only this big. You don't need that whole humanoid robot to do the same function as something this small, which is a few sensors, a few cleaners. And the robot on the right is actually Opera. It's a social robot from Japan. And what it does is it has a screen for communication. It has, it can display television, weather, news. It's basically for social interaction, and it's great with kids. It's actually very interesting because it's also only this big. So we've managed to compress this kind of advanced technology into such a small form factor, yet still keeping it user-friendly. It's still keeping it at the level of that meets our demands and our needs. They've managed to keep this user-friendly, keep this in a very small form factor. They've managed to keep it relatively cheap. So I think that's why we need standardization, because if we can implement this technology into other fields, then we can have this kind of compatibility. We can keep it user-friendly. We could profit from more research. And then, of course, I believe this is the most important application for us right now, because robots can one day save lives. There are nanobots that are being developed right now. I don't think they're fully functional yet, but they've come a long way from where we were maybe a few years ago. And nanobots can one day be injected into the bloodstream and solve problems remotely, like on their own. And by problems, I mean such conditions as cancer, diabetes, and several conditions like that. Because what they can do is they can go and they can either kill or manipulate these cancerous cells to actually become healthy again. And with this, we could even save patients that are ailing from cancer, that are ailing from such conditions. And I think that's very important because, what did I say? I said that robots are meant to ease our lives, and what better way to ease your own life than to cure your own disease? Robots can one day even perform surgery. We won't need doctors anymore. They can do other fields. I mean, I don't like the doctor's office, but I feel like even if there's a surgeon, then we can have a robot do that job. We could save money. We could make it more efficient. And there's a robot now that actually, it knows all the surgical tools. It has all these at their disposal. It goes by verbal command. It actually hears, say, all right, pass me the scalpel. It will bring the scalpel from its own inventory and hand it to the surgeon to use. So we can make this device more precise and more functional, then we can even have it perform the operations itself. They can make business more efficient. Robots designed for telepresence, maybe we never put inside an office again. I understand there are a lot of scientists that couldn't be here because maybe of volcanic ash or other conditions. Imagine if from their hotel they could just have rented 2 telepresence robots to come up here. You could plug them into the projector and they could give the presentation remotely. Well, it's possible. It's just not mainstream yet. I was reading an older copy of this magazine, IEEE Spectrum. It's from September 2010. And the cover article is My Robot Myself. And this editor, Eriko Juizo, he actually stayed at home one day. He rented this $15,000 telepresence robot. He sent that into the office for himself. And those were his eyes and ears around the office. That's what he did. He sent this robot into the office and interacted with his colleagues for him. And he did this for a whole day. I mean, and it worked. So I believe that one day we might not even have to go inside an office. We could all work from home. We could all spend more time with our families. And we could one day maybe just have these telepresence robots communicating with each other. If they could perform on their own, they could take data, they could take notes, they could communicate. Then at the end of the day, you take a USB, you could download all the information, and you could have your day's work right there. So this quote is what he says about these kind of wireless robotics and specifically these telepresence robots. I just want to read what he says. If the visionaries are right, seeing the world through a robot's eyes and roaming around in an artificial body will become a familiar experience for many people. So don't be surprised if one day you're asked to vacate your office and start working from home. Your avatar may be on its way. So what he's saying is that this is happening right now, but it's just not. Of course, it's like not everybody can afford a $50,000 robot to just send into their office every day. Maintenance costs are expensive, but one day this may be cheap enough to become possible for every employee, every worker, every researcher even. And one day we could have robots doing research on other robots even. And I find that interesting too because we might become obsolete. Robots can also go where humans can. There are a lot of conditions that robots don't succumb to that we do. I know I'm susceptible to sulfur gas, toxic gas. I know all humans are. Also lead poisoning. And even fear. Robots aren't scared of anything. They're not built with emotions right now. So I know that if there's something that I would hesitate to do, I don't like spiders. So if you ask me to go into a spider cave, I'll say no to clean it out. But if there's a robot that can do it for me, I won't hesitate to send that robot in to clean it out for me because he doesn't fear the spider. He doesn't fear the spiders. It's not susceptible to any gases that may be in the cave. This is the groundhog mining robot. It can mine in the midst of dangerous chemicals and gases. So I know there's a lot of coal miners, a lot of diamond miners that are susceptible to a lot of things like they get emphysema a lot because of the toxic gases and the lead poisoning. So there's a lot of these robots now that can actually take the place of work jobs where humans would rather not do because those are very dangerous jobs for humans, but not for robots because these parts don't wear down from these gases. Oh, I think I have one more clip. Okay. So this robot, it demines and it also it's an automatic robot and it can also sense landmines. So normally in the Army you'd have a human searching for landmines with a very long sensor, but this robot can do it by itself. It's autonomous. It scans by itself on non-flat terrain. It gets this terrain by a camera. So what it's doing right now is it's actually looking for these landmines. It's got a lot of additional features. It's got manipulated remote operation, marking systems. So I think the clip that just goes on about this for a while, but the point I'm trying to make is that it's fully weathered. But the point I'm trying to make is that this robot could one day take the place of humans searching for landmines, and one day could again save lives and maybe where human jobs would rather not do. This robot can do it as well. So yeah, it can actually when it finds a landmine or it finds something that it's looking for, it can actually mark it by itself. So that's impressive to me. It's got right there. There's a blue X. It can search for anything. Can show anything. So it'll mark a plate. It'll dispense a plate, and it can because what it does is that it can actually dispense this kind of plate, and that'll show where the landmine is or where the foreign object is. So it can actually mark these plates. So we've talked about Earth. We talked about the applications right here. What about the final frontier? This is where we wanted to go for years. This is where the Russians did it in the 50s in the midst of the Cold War. This is where the Americans did it in 1969. We sent a human to the moon, Neil Armstrong, Apollo 11. But what we as humans have never been able to do is go to planets where either the distance to that planet is too long or too far, or we just can't work on that kind of terrain, because I know Mars and Venus, planets like that, have a lot of toxic gas. So we sent robots instead. Robots have taken us into the depths of space beyond that of any human thus far. The most popular example is the Mars rover Spirit, and also its cousin of sorts, Opportunity. These robots were sent, I think, in the early part of the decade, 2000, maybe 3 or 4. And these robots are still actually on Mars today. I understand that Spirit, they've actually lost connection with Spirit very recently. So they've chosen to terminate connection, but they also have Opportunity, the other wireless robot. And that's still collecting information on its own. It's powered by solar panels. We're not manipulating Opportunity from Houston or NASA. It's doing all this work by itself. We've actually managed to make a robot that can go to this foreign planet and collect information, collect samples all by itself. It can move its way out of any dangerous situation. And even satellites are technically wireless robots because we send them into orbit and then we don't manipulate them. They work on their own. They work in their orbit. They collect pictures and data. And we send satellites even farther than Mars. We sent them into Pluto, Neptune, planets where it would most likely at this stage be impossible for a human to go. Maybe in the next 20 or 30 years, but right now we've got wireless robots doing that work for us. Even driverless cars. I know I'm not the best driver. I got my permit a couple months ago, so I haven't had an accident yet. But knock on wood. So Google's driverless car project consists of it's a wireless robot that drives. It's a car. It's just they bought this Toyota Prius, and they modified it to run on its own power, to run by itself. It has sensors. It can detect objects. And inside the car is one engineer from Google and one backup driver. And so far, the backup driver at this stage hasn't actually needed to take control of the car because the car has done so well. They've actually had 0 accidents. And I can't say that for the human population because we have accidents every day, but these cars happen. So I figure maybe if one day, if money providing, reason providing, that we could actually all have these wireless robots driving us around, then we might never have an accident. We might never have collisions. And I really like that because although I like driving, I don't like all the traffic. When I was from the hotel driving here, there were bikes going into the middle of lanes. I thought I was going to die that day. It was dangerous, but if we all have these wireless robotics, then I feel like we could have these robots do the work for us. They could be driving, they could have sensors. And we've had cars for years that could parallel park themselves. There was a Lexus back in 2002, 2003 that you would just place where you wanted to parallel park. It would do it by itself. So we've had this technology for a while. We've just never implemented it in such a way that Google's been doing in the past couple of years. Even in terms of planes, jumbo jets on autopilot are technically, in essence, wireless robots. What they're doing is mimicking the behavior of a pilot. They can take off, they can land, they can fly to a destination by themselves. The only reason the pilot's still there is just to ensure safety, which is, I believe, why the backup driver's been there for the Google project. So these jets, they're very large wireless robots, and we've been able to fly. I came from Princeton to Zurich to Nice, and that was, most of it I'm sure was done by this jet on autopilot. So I feel like that I was actually surprised when I found out that this plane could fly on power without any need for a pilot. And even UAV, unmanned aerial vehicle radar planes, these have no backup pilot whatsoever. There's no crew, it's just internal systems. It's an unmanned aerial vehicle, and it's basically doing the work of a recon team. It can go take off, it can fly itself, so you don't need a pilot, and it can even take pictures, it can map out terrain. It's basically for reconnaissance purposes. So in a dangerous situation where we might have an Army crew or a Navy crew sending out these scouts to go map out terrain, we just have this robot doing now, which I believe is a lot better than risking human lives. So there are a couple drawbacks. We're not at this stage where we can just say, oh yeah, we have these wireless robots, there's no problems at all. So I think the problems are range and battery life mostly. So battery life, if we're trying to get robots to mimic our behavior, then I think we need to have robots simultaneously eat and work. I told you before, I don't need to be plugged in at night. I don't feel like our robot should have to be plugged in at night. I think we need to develop more efficient systems of battery charging, and I think we need to have more powerful batteries. We need to make it that they can be charged and work at the same time. And I also believe that we need a greater range. They need to be operated from a farther distance. Even with that first Army robot, you can't have a human operating it from 5 feet away. You need 50, 500 feet away. Although hybrid systems that use a mixture of power trains are being developed and there are range extenders, I don't think that we're at the stage where we can just call it a day and say, okay, we've got this technology. I think that we need to keep developing and keep researching to perfect and get rid of these drawbacks. So, what does all this mean? Why am I saying this? Because in the years to come, wireless robots will be integrated into our lives more than ever. I feel like as we grow, the robotics population in the industry will also grow, I think, at a rate faster than we can cope. So I think that with advanced technology, science will continue to make strides. So we need to be able to research and cope and to deal with this kind of technology, this kind of growth. And paradigms are shifting, which means that there will be a whole new era for robotics. I think that the stage we're at now, in 10 years, will be something of the history textbooks. It'll be ancient technology. So what can we do to accelerate wireless robotics? What can we do to accelerate this field and get to where we want to be? To make this, to meet the needs of the people, I think there are a few things we need to do. I think we need to clearly define these goals and objectives for this decade. I think by 2015 we should have this done. By 2019 we should have this done. I feel like we need to, I think, maybe make this policy more rigid. I think we need to define where we want to be by what year. And I know there's a lot of people that have these projections, but I think we need to collaborate on these projections that have universal goals. I think we need to compress Watson-like technology into the bottom of a human brain. So Watson is about maybe 3 or 4 feet high, tall. It's one computer. It's better at recalling and storing information than the other two Jeopardy champions were. But of course, the only thing that the humans were using was maybe the size of a grapefruit. It's just a head. It's just their brain that's been compressed. Watson, it needed this whole computer to perform that one function. I think we need to compress that kind of technology into a very small form factor, so it can be implemented into even the smallest robot. Maybe that the Papero device that's maybe about this big. We need to get that kind of technology into something maybe a little bit bigger than that, or even smaller than that. I think we need formal research for a lot of different topics, such as power generation, wireless sensing, self-regulation, power conservation, heat dissipation. I think we need to fund formal research for all of these topics so that we can collaborate and we can, I think as a human race, we can use all this research to better the robots we have today. So I think without this research, I don't think anything will get done. And most importantly, I believe that standardization can help interoperation and acceleration in leveraging distributed skill sets. So basically what that means is that you've got someone maybe in Germany who's working on a control unit, someone in Russia who's working on the code, someone in India who's working on something else, maybe someone in Japan is working on something else. If we standardize the technology, nobody will have to work with this fear of incompatibility. If we standardize everything, we can get to these fields and we can meet these demands much quicker than we would without standardization, because everyone can collaborate and everyone can work together without having this fear of incompatibility, saying, oh, what if what I build in Russia isn't going to work because I have different technology than whoever's working in Germany or in India. If we standardize to, I think, a very certain extent, then I believe that nobody's going to have that fear. We can all work freely without worrying about this, and I think we can get to somewhere farther than we ever would have been able to before. So thank you for your time. If anybody has any questions, I'll try to answer as best as I can.
Much better than what I was expecting. And it's a great opening talk ever I had heard in my lifetime. Thank you very much. Any question to this young man?
To accelerate things, why is there a need to compress the Watson type computer into a robot? You could also have it sitting somewhere else and have, let's say, the brain dissociated from the robot as a sensing and actuating system.
Well, I mean, I believe that no matter what we're doing with wireless technology, I feel like even that length of communication will still be, there will still be drawbacks to that. So I figure there are two ways to go about this. There's exactly one way that you said, which is a very good idea, but then maybe there's also compressing this kind of technology into the form factor. And I don't know which one might be easier, but that would depend on who wants to get the research done. But I believe that you can go about it two ways. You can have this Watson kind of base station communicating with these brainless drones that would just operate solely from this base station.
Right.
Or you can compress this technology into the robot itself. And I feel like I mean, there's technology like an iPod shuffle is only this big, right? It doesn't go to any server that's this big. So if we've done that much, we've compressed a very large record player maybe 40 years ago into something the size of my thumb. So I feel like if wireless robotics are headed in the way that industries have historically been headed, then I think that it would be a lot easier, just from my perspective, to compress this technology into the robot itself.
Two more questions, I will go. We are getting late. I say, yes, you are.
I'd like to continue. This was very good question which was asked, and I appreciate your very good talk. There was the first video. It was taken in Aalborg, where the LROP event was taking place. I've been arranging that and been involved with that all the time. It has been, and the main drawback, if I simplify, during these 10 years during which we have been arranging it, has been that there is a failure of communication. And it's very hard if you are in the wooden area where there are a lot of trees and other obstacles, which very quickly loosen all the communications.
Right.
So there is a challenge, and I think it's a very good challenge for this group if we are going to make wireless robots. And I definitely agree with your analysis that we shouldn't put everything on board, because we have this wireless possibility and we have this cloud way of having more capabilities for our robots whenever that is possible. But we have to be prepared to that stage also, where the robot has to be its own and functioning.
Well, I think it's all about compromise. I mean, because like, as you said, that there are problems with trees, problems with terrain. I know that when I'm in the woods, I can't get a signal on my phone. So how is a robot supposed to get a signal to a base station? I think with today's wireless technology, it'll be very difficult. But I think we need to compromise. We need to put some technology and compress that into the robot itself. But then we also need the wireless aspect where it can be pushed into a base station where they can communicate. But I don't think you can go one way and then one way. It's not a fork in the road. It's a fork where they converge at another point in time. And I feel like that conversion point is where we need to be in the next 20 or 30 years, because if you can communicate with a robot, but also if something should fail, if the robot can work on its own and go autonomous without having to communicate wirelessly, I think that's the best situation, because you've got that backup where if, yes, you can communicate, which is ideal, but if you can't communicate, then what does the robot do? It just sits there. But if it can work under its own power, then I feel like we've got the best of both worlds there.
All right, thank you. Now we will continue this discussion during the coffee break and lunch break. I think we have to go ahead, and young boy, you have to copy your nutrition, the golden ring, and give you back. And then you have to write a full paper also for the journal, you know. Your